Okay. You ready? Can we continue? Okay, so let's now have a quick think about how we're going to spawn agents in this whole system. Well, first of all, let's go into that agent prefab. I'm not sure why it ended up with non-zero starting position. Okay, I don't want that. Maybe vertically, I don't know, but yeah. We might need to have 0.5 here, but the size is also too large. If we actually place that on those roads, then there won't be we won't be able to fit a lot of agents there. So let's bring it down to 0.15, 0.15, 0.15. That should be pretty good. Okay, where do you think would be a good idea to spawn the agents from? Which component or which location? Yeah, that's one way to do it, but then it might be a bit tricky to determine the the goal. Like, where would we actually pick goals? That would become a little bit tricky. So okay, I decided to just do it the other way around, that we'll spawn them everywhere and make them go back to the origin. So let's see if we can make something like this happen. So this would have to happen in the root tile. So that's the most logical place to really put it in. So let's go to the update function of the root tile. Not sure if there's already one. There is, yeah. And let's make some decisions. Let's say that first of all, we'd like to make sure that the Navigation City Manager already has a nav mesh baked. So let's make this check. If, first of all, if Nav City Manager is not null, because in the beginning, you know, maybe for some reason this hasn't happened yet, and it's very unlikely that this update function will it's actually impossible, but you know, null ref is a problem if we try to do something with the unassigned variable. So it's not bad to be a little paranoid in this case. So if Nav City Manager is not null, so which means that we already have the instance of the Navigation City Manager, and then we can use it. So if Nav City Manager nav mesh ready, if this is true, I could make it explicit equals true, but as you know, you don't have to do that. And also, would we like to use all the tiles, or maybe only spawn agents on the flat tile? I think flat seems a little bit more safe, just in case, you know, we kind of end up not exactly on the mesh or something. So there is a variable here which is called mySlope, and if this is equal 0, it means that the current tile is flat. Oh, this time I cut it. Alright. So if this is all true, then we can think about spawning. And we don't really have a reference to a prefab, but the Navigation City Manager, well, we can put one there. So let's add a Navigation City Manager in the beginning, in the field section. Let's add agent prefab. Just need to make sure that you remember to populate it. Okay, Navigation City Manager, just add a public transform agent prefab. Go back to root style again. Okay, and now let's do a random. So int rando is equal to random range between 0 and 1000. So let's go for something like that. And if rando is less than 5, so fairly unlikely, but that's what we're gonna make so that we don't oversaturate. Let's instantiate, and now we need the reference to the agent prefab. So nav city manager, we have the reference agent prefab. Can you see what I've done there? I didn't want to hold references to prefabs in every tile in the city, so I just used a reference from nav city manager, and I used that to instantiate. And now I need to have a position, so this transform actually does it. Does it? No, it needs to be this transform position, I think. Oh, okay. This is where I made a mistake. Okay, is this clear what we've done there? So all the time, you know, it seems a little bit excessive, but you know, these if statements, most of the time they'll be false. So, well, actually, sorry, I'm lying. This one mostly will be false. So this is just going to be lots of checks on all the tiles. So maybe not necessarily the best way to do it, but keeping it simple, it's okay. It's not gonna kill the performance. Is it okay? Did you duplicate it? Okay, and let's go back to our pursue goal. And we actually want to have some safety valve. So when we start our agent, when you instantiate this object, start method is being run. So let's make sure that this, yep. On city manager, navigation city manager. Yeah. Okay. Well, yeah, don't run it yet because yeah, you need to have it there, and then just a safety mechanism. Let's suicide each agent after 10 seconds. 10 seem right. Let's see what happens. Okay. Sorry. Okay. So just destroy this game object 10. Like just this would have been not enough because it would just remove the pursue goal component, possibly not the actual game object. And this gives you this overload of the destroy function gives you additional float for time of delay. So this acts almost like a coroutine that would delete it after 10 seconds. So I'll save this. I'll just check. Okay, am I still recording? Yeah, all good. Okay, and another thing, those agents don't really have anywhere to go. So in start function, well, what do we need? Any ideas? We need to get we need to get the start location now from the nav city manager. But to do that, well, first of all, nav city manager, if you remember, it's in namespace grid city, so we need to make sure we're in the same namespace. Okay, all this code needs to go inside this namespace, which will then allow us to have a reference to the navigation city manager. Right? We need to do the same thing we did in the root tile. And on start, we need to populate this. So we're grabbing the instance of the navigation city manager singleton. Once we do that, we can use the nav agent destination, and this looks for world space position. Okay, this gives me an error because this is a transform, so we need a position. Okay, able to follow? Okay, so let's see. We've set up the destination for the agent, and here, delete this from the update, because that would have conflicted now. And as a matter of fact, we don't need this goal anymore, so let's kill it. Okay, so let's do a quick test if anything is happening as it should. Okay, city is in, roads are in, and nothing going. Okay, nav mesh surface is built. Okay. Oh, okay. I told you how I'm gonna forget to assign the prefab. Well, that's what happens. So nav city manager needs to have the proper reference to the prefab, but only in this one spot. So we set it up so only the nav city manager needs to know all those things, and the other ones are grabbing it. So that's the need and the reason for a singleton. Cool. And whee! Little lemmings. Is it working for you? Cool. There are some problems with the city mesh being so, the nav mesh being so large. I think that it's basically at some stage it's overloading the system, so let me try it a few times. I've noticed that when you do it and the roads are kind of on the small size, small number of tiles, this tends to be more robust and like remains behaving. So you can clearly see where the crossroads are from the very beginning, so this must be the start location. Yeah, indeed this is. Then after a while things are breaking. So okay, let's make a modification. The navigation city manager, let's suppress it a little bit. I think that was a bit too much that I've given it. Sorry, it's in root tile. In root tile, in here, the biasing randomization. So how about I just divide it by 20? So that will change the odds a little bit in favor of smaller city. Much smaller city right away. So we see that we have a kind of a process like something like from telecommunications. We have lots of connections coming and then they are disconnecting after a while, and then we maybe have an overflow here. Nobody knows exactly what's happening here because they seem to be overlapping. Yeah, it's a bit of a mess, but anyway, we can control how many of them are being spawned by using that rando variable in the root tile. So remember, it went into update function of the of the root tile. So if I use 50 instead of 5 here, what would you expect to happen? It will be much more likely to spawn, and we'll see how quickly it will kill performance. Well, I don't know, maybe I'm pessimistic, but with these things you have to be careful because there's a lot of those blocks. Like once you kind of generate a lot of them, that's there's going to be lots of spawn points. So oh, this is not going to be happy probably. Okay. Yeah, it seems to be actually kind of a lot of them start out and are static, so I'm kind of wondering about that. Yeah, so I'm just wondering if it's the positioning of the capsule. It's not close enough to the nav mesh, or maybe there's a part of the mesh that's cut off, but it does seem to have to do with the amount. So I have to read up on what's happening. It's not like maybe necessarily a typical case of using it with so many little objects just to show off. But I'm getting a feeling that might be the case there. I'll try to verify and look into it because it's actually kind of quite interesting how when it works. It's quite interesting. You can kind of get almost like a crowd simulation thing going. Anyway, let's make things a little bit more interesting and practice our coding. So in pursue goal, how about we change the color of each agent being spawned randomly? Would you kind of know where to start with this? So if you look at the agent prefab, or any object for that matter, to be able to access for mesh render and then material and then color. So let me just quickly whip this up. So we will need I'm not going to create any additional variables for this. I'm just going to try to kind of do it in one go. So render rend is equal to get component render. Should be kind of slowly becoming second nature, this type of stuff. Okay, and now material mat is equal to rend material. Okay, and now mat color equals random color HSV. So there's already a nice function for us to randomize a color. Does this make sense? We're grabbing a reference to the renderer component on this object. Then we're getting the material reference from the renderer. You can see what the renderer contains. Like you can see that, let's have a quick look. There's materials, there's motion vectors, name, probe anchor. There's a lot of stuff, but at the moment we only care about the material. Should I leave this on screen, or everybody got it? I could probably make it even more compact. So let's have a look at using dot notation. So I'm not going to store this in any variable. I'm just going to use this dot notation. So I'm going to directly access the field material. And then directly access the color of it. So there you go, one liner. Just in case this dot notation was giving anyone trouble, that's the kind of equivalent. I'm not saying this is better necessarily, or it's maybe less readable, but I mean, why even bother with those local variables if we're not using them later? We're just using this once. So let me save this and see what's happening. Okay. Okay, so maybe it's not super visible right away, but okay, you can see that all the colors are randomized now. So yeah, some kind of opposite to social distancing is going on there in this city. So for kind of moderate amount of spawners, it seems to be, I don't even see static agents, so it seems to be working okay. So it's kind of worth looking out for what might be happening there. Maybe it's where NavMesh is corrupt and some mesh agent causes problems and the whole system breaks down, which would be kind of worrying. So this is kind of actually good, a good test for pushing it to its limits. Same result everywhere? Okay. Did anybody run into the breakage or static agents? Or well, let me run it once or twice again and see if anything happens. Still happy. And you can see that there's a little bit of logic there to the agents. They even adapt their speed a little bit. Like when they start from zero velocity and kind of speed up. So there's a little bit of like a physics type realism there. Well, let's have another look at. We kind of went over really quickly over some of the parameters for baking the NavMesh. Especially here in advanced. Okay, I can't really do it in runtime. Yep. Yep. Well, I think yeah, I think it's fairly safe to assume it would have to recalculate its path. I'm not sure if they would like just stop doing whatever they're doing. I think if you set a destination, it should be okay. But it's worth experimenting. I'm not exactly sure. I'd say it would probably stop and recalculate. Maybe you need to actually set the destination again. I'm not sure, because it seems that when you do it once. And something goes wrong, then I think it just will stay static. But don't quote me on that. Let me check something here. Like we've fast kind of like flew over lots of options here, and I've already had also these humanoids set up kind of pre-configured. So just like have a quick look at what exactly is happening there. You have a general idea of the agent type. We need to make sure that the path is wide enough for the type of character NPC that you have in there. So that's why you have the radius there. You have a step as well. So you need to make sure that certain kind of a jump discontinuity and the ground will not cause a problem. Will allow it to jump over it. So open agent settings. And the max slope. So now if I reduced the max slope here, I would assume that things will break terribly, because our slopes are at least 45 degrees, I think. So let's have a quick check if it will create lots of separated paths. Indeed, so it cannot handle our slopes. And now you see that the agents actually are trying to get somewhere. and they kind of go in more or less the right direction, and then they get stuck. So that's, you know, kind of like it is a good test of what is actually the implementation is doing. I'm not sure if I can change it on the fly. Not really, because now we'd need another button for rebaking. Maybe we could add that back in. So navigation city manager. Remember how we did this in the very beginning. In update. So if input get key down, key code space nav mesh build nav mesh. So I'd like to just quickly play with some parameter changes and see how it all will affect it. Because these are very regular pieces of geometry, kind of predictable. This slope and that. Now with a kind of a more artistic set of assets, you might have problems with you know, suddenly artificial boundary somewhere because of you know, one vertex being too high or whatever. So let's test it out a little bit, and also we'll test the thing you asked about. So what's happening? We have some live agents already working there. Okay, let me rebake. Okay, so they just resumed, so it's not too bad. Oh, okay. Well, I didn't observe it right now, so it seems to be fairly performant. I mean, like, it is meant to be dynamic. Here I've got like the visualization for all the, you can see which segment of the nav mesh is being traversed by a specific agent, and also kind of like some visualization of the direction and whatever they're doing. So interesting. Areas, this is nav. Okay, let's go back to the nav mesh surface, because this is where all our important settings are in inspector. The voxel size, I don't know if I showed you the difference. So this is like the area, the geometry is voxelized for this calculation to create the surface, kind of turned into volumetric pixels. So this is a small enough kind of voxel, which makes things very kind of nicely behaved. But what if I like increase it to say 0.1 and now we bake? You see that like things changed. It's a little bit more crude. What about if I go even further with this? See, it totally breaks, so that's not sufficient resolution for this this type of distances. And it all depends on scale, of course. So now our surface 0.15. Oh, this managed, but just barely. You can see that it's kind of fairly irregular. So you need to, with all these parameters, it's kind of like all. First you need to make sure that you're getting good results. So this is, you know, kind of a good testing system. What else? Tile size. Well, the humanoid settings. So what if I have a much higher radius? They're too large to even move, they're stuck there. So bring it down, rebake, and the ones that were static seem to have stayed there. So that is potentially a problem. And I'll make them very thin. That should make the effective path wider, and they shouldn't be kind of like getting stopped a lot. And yeah, I'm not sure about the start location. It usually should be a 4-way. So something, oh, I see a kind of an indication of a error. So this crossroads actually got deleted by either the building or something that's next to it. So either this block tried to build a block to the side of it, or this building mapping or something is just not working correctly. But anyway, it's a kind of a minor thing. I'll have a closer look later. Yeah, okay, so that's the nav meshes. I think we can you know, maybe do a, let me have a quick look there. How many of you managed to get your hands on the Harrison book, by the way? Okay, I realize it's not in the library, like I didn't have access. You all have it? Okay. Okay. Well, that's great. It's a nice book. It's support the author if you can. I did buy the Kindle, so. Okay, cool. So yeah, for this, there's a kind of recap of this, you know, pretty much around the topics we're talking about without the procedurality in basic AI and enemy behavior. So maybe if you need a kind of a slightly different perspective on it, they give you it, and so that'll be from navigating in Unity to time for action patrolling continuously. The stuff later on might be more relevant to integrating it to an overall game manager, so like I wouldn't recommend you necessarily to read it as a baseline, because otherwise you'd have to be up to speed with everything else they've done up till that point, so maybe it's a little bit awkward. I didn't want you to be confusing yourself, whatever, but also there's a little mention about refactoring and keeping it dry, so don't repeat yourself acronym there. So that's all relevant. Pretty much everything in this book is a good thing to know, and regarding C#, it puts it in a kind of a Unity context and teaches you concepts. So and, you know, I'm enjoying this book myself. As I mentioned, the Brightspace, I've set up the course, so please enroll. This is the image for it and the name for it. I think I already put the image there on the screen, so let's do that, and it'll be easier further down the line. I apologize I didn't do it earlier. It was kind of, I didn't get access until fairly late in the game, so I need to just get up to speed on the whole layout of the thing, and as some of you pointed out, it's a better place to be you know, putting grades and whatever. I will DM you with the creative assignment results. Mostly everybody did pretty great there, like I said. What I'd like to do and start doing next week, now in 2 weeks it's reading week, right? Already. Is that right, or am I 1 week off? Yeah, well, that's what it looked like, the calendar. So I did schedule like a lab test 2 in 2 weeks. If it's reading week and we're not having the lecture, then it will be more like a, you know, partial assignment, which would be kind of something not to make you do extra things outside of the final project, just something that would be useful for the final project. So what I'm thinking is kind of a version of the creative coding assignment that you did in Blockly, just done using you know, the procedural city blocks. So basically playing around with shapes and different body, kind of like city building shapes, and and variations and placement, and being comfortable with using the city array. So definitely, if you know, I think after doing the tree tower and going through the road code, you know, doing something simpler like that, like a rectangle which starts at a certain point, ends at a certain point, and make sure that everything inside has been checked with the city array. That shouldn't be a big problem. We can maybe have a quick look today at making a little bit of a simple tower structure or something that doesn't use profiles, doesn't use recursion, just kind of like a simpler one. I prefer to kind of like front load the difficult bits, because these are the most useful for expressive, for letting you actually play with the system and having something like unique and creative about it. But we can just maybe dial down on the code difficulty and just see where everybody is comfortable, so that you can do your own stuff without being too stressed about I don't know, like lots of troubleshooting with recursion, for example. I'm here to help you, so also ping me if anything is giving you problems. Just let me have a quick look. So yep, I've mentioned all this. Dimensions, coroutines, yeah. When you're working with NavMesh agents, make sure that, well, first of all, like you saw, that the NavMesh is present, and then that the agent is placed somewhere on the NavMesh, and that the destination is set. And then it should hopefully just work. Okay, we already had a break, so let's just carry on with this. So let's start kind of like free-form thinking about what else could we do with this city. So let's make a plan of dropping some large building in the middle of all of it. That would be just like one big cube or one other model, something simple enough, but still we would like it to work well with all the other bits, with the roads and the other buildings. So any ideas what would be the best way to do it? Especially, I think what you might find limiting is the scale of the default building. It's it's pretty restricting. Everything looks like a bunch of Lego blocks, so maybe that's not the look that you're interested in going for. So what can we do with scale? Can we actually have a multiple building that has a mesh that takes over a couple of spots there? I mean, obviously we can. So maybe let's create a new script. Before we go on to this, any questions to the other parts today? We're kind of move away from the nav meshes. I think there's like only so much you can talk about one time, but we can come back to it next week. Oh, one interesting resource, I think I've seen somewhere, there's a very nice Brackeys tutorial, nav meshes and animated characters. So if you have like an ambition to make this very game-like, I don't let's see, there's even making a dynamic tutorial for NavMesh. Okay. If you can stand the guy. Oh, here. Okay, so I think this is a fairly nice tutorial to have a look at, so I'll drop it here in the text channel, because it ties in what we talked about during the animation lecture. Well, I know that you've already had other, some of you maybe have other takes on the animation. Okay, so what's the problem statement now? Let's suppose that I have 2 points and I'd like to just stretch the big block between them. So that's a little bit of a challenge in there, but let's maybe attack it. So which script could we adjust to? I don't know if it's even worth it to create another script for this, but maybe let's go with this nav tower block. It's your plain, you know, building generation one, which has a lot of stuff we don't actually need. So let's call it nav test block, or nav parametric block, to make it fancy. Okay. Okay, lots of this stuff that we have from the nav tower block we can get rid of. We don't care about mesh filters, renderers, my mesh, my material. We don't care. We're gonna just assign a material and a mesh to it, and just make sure that we scale it correctly. And then afterwards we will make sure that we fill the city array with the right values. So navigation city manager, maybe that'll be handy at some stage, but max level, recursion level, no. Base prefab, I don't know. Yeah, let's leave a you know, prefab. Yeah. Building profile, let's kill it. Let's just make it really simple. My profile, max level, kill. Set profile, kill. Initialize. Now this is interesting. All this goes. There's nothing left really. Awake. Yeah, this can go. This is interesting because we definitely need at some stage to remap something from something to the from world position to the array indices. So let's drop it here into the initialize, but we'll have to work on this. I'm sorry I didn't zoom, so city manager instance, yeah, let's leave it there, let's initialize it, and then all this stuff that comes after that we delete. We don't want this. And update if transform position less than -5. No, we don't actually need this either. Okay, am I going too fast or? Okay, so let me zoom out just for a second. So we have our new parametric block class, and I didn't leave much there from like a very empty little new mono behavior. So there's nothing really in update, so I can even delete it. That's actually a good idea, to delete update functions on objects which don't have to have them. Okay, so initialize. What would be the best way to provide those parameters to build our block? Any ideas? We were talking, you know, building a, say, a cube or a big rectangle from like one spot to another. So why not have 2 points? Why not give it 2 points and make sure that you know, everything between those points, so like a top bottom, like a bottom left and top right type of setup. We can kind of call it like that, or start point, end point. So let's add some public transforms. So we can declare them in one line here, just start point, end point. And how about we use them to run this initialize function? City or navigation city manager? We're not using. Oh. Did you rename nav parametric block? Yeah. Yeah, that's probably what we'll do it. Okay, so what would you like to do in initialize? Well, we're going to be rescaling our mesh, our basic transform, making sure that we're in the right location, but also we will be using the set slot functions. So we will have to be kind of we will definitely need to know where we're starting, where we're ending. So for this initialize function, let's take 2 vector 3s. So vector 3 start vec and vector 3 end vec. And this is obviously subjective and arbitrary, which one means what. So we also need to be careful about you know, what we do with them, because if you give a user, you know, a way to provide a you know, bottom left, which is on top of the top right, they will use it, and you know, the whole thing will, unless you're careful, it will break down. So we have our that would be our minimal parameters for this function, and we're going to run this in start function. So as soon as this gets created, let's just run the initialize function with start point position and end point position. Okay, does that make sense? We're just kind of taking the public fields of start point and end point and relaying its positions to the initialize function. Okay, so we're kind of like getting a little bit more confident with functions and just sending some data to the other function. So position is a vector 3, so we're good. And now this remapping now. So it might make sense to actually have some private variables which store our array index, and let's call them in a kind of very formalized way, so that we actually know which one is the bottom left and so on. So yeah, let us go for int bottom left int. So let's call them so that we know their indices. So bottom left index x, bottom left index z, bottom left index y, so the vertical. Okay, maybe just to make the line shorter, I'm just gonna duplicate this, and top right index x, top right index z, and top right index y. So these are all separate integers, and we will use them to access the arrays indices. And I think this would make it easier for us to, because we will make sure that these actually are what they are called. So let me know when you're ready. Okay, so first of all, let's run this on the start vector position. So let's call it start x, start y, start z. So we have the rounding to integer from floats, because here from the position we will get a float. We already added the 20, so this is kind of remapped. Okay. Okay, I'm duplicating this again, and I'm going to go with end x, end y, and end z. So let's assume this whole thing is just one chunky block. So now we can work in this left and right. So let's say that left is west and right is east. So I can have this standard convention that we've been using up till now. With Z forward being the positive, Z positive. So bottom left index X. Let me just copy these. Just copy these so I don't make a typo. And what I'd like to do is okay, if start X is less than end X, then what's going to happen? Bottom left index X is this safe? Yeah, because basically the smallest X coordinate is going to be our bottom left index X. So start X and then top right index X, unless you end equals end X, else okay, I got you here. So private needs to have a access modifier, of course. What is it? Shouldn't be a problem. Oh, okay, yes. Good. Yeah, thank you. So this is really irrelevant here, but well, private makes sense anyway. Yeah, sorry, it's the screen size. I was just they're actually like huge. So it's almost hard to read. Okay. So this kind of basically sorts if start X is less than end X. We need to do the same for the other ones, so it's a little bit clunky, but maybe we could just factorize it as well later. But if start Y, it's easy to change, so if start Y is less than end Y, then bottom left index Y is equal to start Y and Y. And in the other case, bottom left index Y is end Y, start Y. So this all kind of might seem a little bit excessive, and you know, maybe it is, but it doesn't hurt to have this kind of really. It's just start z. Okay, with the Z, okay, now I'm not sure, bottom left, so this actually would mean bottom left, front and back type of thing. I think we need to actually be very specific. Okay, you know what? Apologies, I'm not gonna go that route at all. Because in case of this simple, like it might be a problem if we want to extend it later on, but at the moment we can just go and iterate, and hopefully everything will be okay. So so let's just iterate. For int x equals start x less than end x. Bottom left, let's say bottom left near and far. Sorry for being all over the place, but I didn't kind of have a proper plan, but okay, bottom left near. Top right far. Actually, I think it will be helpful to have it, you'll see in a second. Top right far. Okay. Okay. I will in a second. Just it made me yeah. Top right. Start Z and Z. So start Z is less than Z, then bottom left. Near will be start Z and start. Okay, and these kind of cut and paste situations need always make sure that you've got the right. So it's worth having another skim where they all match each other. So this is our Z section. So if the first point is on the closer to you, then this is going to provide the Z for the bottom left near, and so on. This will make it easier to iterate as well. So yeah, let's just iterate through the whole lot. That's going to be easy now. So int x from bottom left near index X. The condition X less than top right var index X, and X plus plus, another 4 nested. I'll just copy it again. So what's going here? This is the Y, bottom left near index Y, Y less than top right var index Y, Y plus plus. It feels like it calls for some kind of, maybe geometrical explanation, but sketch it out for yourself. I think it'll be kind of clear what we're doing here. We're just filling this okay, so X, X, Y, Y, Z, Z. Very easy to make a mistake here, so okay. And all that needs to sit here now is set, sorry, we are in, yeah, we are set slot. We have a reference to nav manager, city manager. I can call it nav city manager, whatever. Or actually, I'll leave it, sorry. I'll leave it because there's already some stuff in there. So, having this reference, city manager, set slot X, Y, Z true, and this makes sure that the whole, okay, sorry, okay, sorry, thank you. Okay, so I've added the set slot, so now I'm writing true to all these cells which kind of happen to be within the area. So we'll test it in a second. How are we on time? Oh, we still have plenty of time, so good. So this is the array side of things. This is the array side of things. Are you good here? Do you have this code? I know that was quite a big chunk. Okay, I'll leave it there. The reason why I remapped this all, it was so that I have them ordered from smaller to larger, and then I don't have to worry about increments. So I can just do this kind of like in a very predictable fashion, and from bottom left near to top right far. Sorry, so my instinct was actually kind of correct. There could be other ways to do it. You can just have some increment and no, or maybe we can, I don't know. I think this was the simplest. However, the next problem we have is that we need the center point for our mesh, and also we need to know how much to scale the mesh by. So we need to instantiate something in the middle of this whole area and scale it so that it fits at the right location. So the original object does not have a render itself, it will spawn a prefab. We just need to know where that prefab needs to sit. Okay, Well, we just made sure that bottom left near index z is a smaller value, and we can actually do this safely, because if we add 1 to z, we will never, like, and these are ordered incorrectly, then we will never end this loop, right? So this was the whole purpose of this little exercise there with bottom left. But also we know now what this variable means. It's kind of like very over-determined in its name. So you know, instead of start and end, which could be, you know, here, there, wherever, we kind of like know where we are. We know which variable to look for if we quickly need just to know the bottom of the structure. For example, if you want to have something flying all the way to it, but not further than that, an elevator or something, and so on. Cool. Okay, so let's carry this forward. We need to find out our midpoint. So we have a start vec, end vec, and these are not rounded, these are floats. So let's just get an average vector. That's going to be our middle point. So vector, let's add a private variable. Midpoint. Okay. And here, midpoint is equal start vec plus end vec divided by 2. So this is legit. You can multiply and divide vectors. We've done this before. You feel what's happening there. We have those you know, 2 vectors there. We've added them together and divided by half. We should end up with a midpoint between them. Oh. Okay. So if you imagine 2 identical vectors starting at the origin, pointing in completely different directions, if you add them together, they will zero each other out, and if you divide by 2, it won't make a difference. On the other hand, imagine that there is a vector of the length of 1, and the other one is vector of the length of 2, and they're both positive, and on the x-axis, the midpoint is at, you can feel it's 1.3. So actually you need to add them to the 3 and divide by 2, and that will end up with 1.5. So that's kind of like pretty obvious when you draw it. So we have the midpoint, but now we need to also know the scale that we need to divide, the scale that we need to set to our model, our mesh. So let's say that our mesh, original mesh, is going to be always size 1 unit size, like all our blocks so far, but we would like to scale it. So I think a safe thing to do is we'll put another vector, scale vec. Scale is a vector 3 as well, right, in 3 dimensions. So here we're storing kind of position and midpoint, and here scale vec is going to be scale on the x, y, and z axes. So okay. So scale vec is going to be actually end vec because NVEC is going to be further out. Yeah, we'll see how this works. Top right far. Yeah, that's right. So NVEC. Oh my god. Actually, this would be good if we. Yeah, it's almost like we needed to make this check earlier on. Anyway, let's not worry about it at the moment. Let's just subtract NVEC from start vec, from midpoint. So if you look at this, yeah, so if I now have a cube which starts at origin and its top right far point is going to be at 3.3.3, then we know that we need to have a mesh which is sized at 1.5 again, positioned at 1.5. We'll have a chance to test it really quickly. So this, let's assume this is the scale vec. So now we can instantiate the base prefab, I think it's called, base prefab, at transform parent. I'd like a position in the world space, so okay, so vector 3 is going to be just midpoint. Quaternion identity, and the parent yeah, the parent, let's say it's going to be the I'll add an origin or something. Yeah, it's gonna be a transform. Actually, the best way to do it is just use City Manager's transform, and we just need to make sure that the City Manager object is at the center, and this way we won't have a problem. Okay, have you got it? Okay, so let's do a test run. Save. Let's pick a prefab for it. So let's just create a new object. Let's call it like whatever, blocks, cubes, whatever, monolith. More inspiring. Okay, and let's call it nav test. What was it called? New parametric block, nav parametric block. Base prefab is going to be oh please. I'm gonna have to make a simple prefab out of a model, I think. So let's use arches. Arches is nice. Okay, and arches prefab. Original prefab. Yep, and back to monolith. Base prefab arches. Start point, and now we need a transform to provide to it, so let's create one. let's just move this one here. Let's move this one there. We're not even worrying about how accurate we are or anything. So this is the start. This is end. Okay. Okay. Let's go to Nav City Manager, make sure it's at origin. It is. Okay. And we don't want this arches there. So it's just this monolith. And let's see if I can reset its position because it doesn't matter. Start and okay. Well, let's run this and see what happens. Okay. I think I need to put the other stuff in at pause, a permitting block. So this initialize function should be called and instantiate should be called. So what happened? This also should have happened at the very beginning. Because it was already okay. Navigation City Manager, timed nav mesh bake. Let's add a little extra yield in this coroutine just for stuff that's already in the scene to make sure that it gets built out, just in case that's the problem. Okay. Let's see what's happening there. Okay, okay, I forgot to add the scale, of course. I'm sorry. Nav parametric block. So we instantiated, but we didn't scale anything. So game object, new object is instantiated. Sorry, transform. And now new object skip. So new object, we can do local scale because yeah, is equal to scale back. I'm curious. What's it gonna be? Okay. This view was kind of also positioned. Let's make sure first that our start and end are kind of like the convention that we agreed on, because we didn't do the check on the vectors, unfortunately. So let's just do this, this and this. Okay, and save. Okay, so we got something. Is it really the right scale now? That's what I'm kind of wondering about. Monolith. It got attached to the Nav City Manager, and its scale is from 5 to 4 and 1. Okay, and where are the actual vectors that we've given it? Start, end. So it's centered, okay. The top seems to be okay. start. No, it's not. Ah, okay. Okay. You see the mesh is centered. All the meshes that we have are centered around the base. So that's where the y variable needs to be always there. So if we actually placed it, okay, so that needs to be fixed. Yeah, that's the kind of messing around that unfortunately you have to kind of end up doing. But it makes sense to have the base like this. So we instantiate not at midpoint. Instead, I'm going to take the midpoint y So it's going to be the minimum value from start vec y and end vec y. I think that's fair. So definitely we got the midpoint okay, it's just we need to land on the base. So is it okay? Can I save and try? Okay. Yeah, you're using base. What kind of error does it tell you? Oh, okay. So I think the scale is actually underestimated because if we treat it like this, we need to double the scale. This is already looking better in terms of placement, but the scale is totally wrong. So I don't know, maybe I'm overcomplicating this, but the fact is that those blocks have like half. Yeah, okay, let's try. Okay. So that worked, a little bit of a trial and error, but and also you see that apparently it did its job. So there was a building that tried to grow underneath it, we didn't let it. So even though this whole thing is a little bit kind of wonky, so let's make it a more sensible monolith. So let's start on the ground. Let's zero the y on this. Let's go here to, I don't know, it's just, yeah, 5, minus 6 is fine, and end is going to be 6, and 15. That's it. No. From 0, okay, to how tall? Let's do it 12. So now we have a kind of a manually parameterized monolith, and obviously it would be easy now to create it by code and spawn a lot of those properly positioned, and as you see they're being avoided by the other buildings. So I think that's an improvement. And also you see the road didn't go into it as well. If this is a specific type of building, like you know, these arches for example, it would make sense that it only blocks out the legs, and you know, so we can obviously refine it, or maybe use it as a combination of smaller you know, primitives or something. But I think this is already kind of like something useful, because then we can spawn another one on top of it that is smaller. Let's try that, and then we can do it procedurally. So I think you can kind of maybe, yep. Yep, yep, sure. Let me just I multiplied by 2. Yeah, okay, 1 second. Just start this at minus, okay, 0, and this at 12. So let's move this up to 12. Start is okay, let's do minus 3 and 2.5. Kind of improvising here, and here's 3. Okay, so this is start here and here. Start here. Okay, that's definitely needs to go that way. Sorry. 5. Okay. 7.5. And let's say 12.5. Okay, how would that look? Okay, so yeah, okay, sorry John, here you go. I will add this code to the finished version, and also I will put that all to master branch after that, I think. I might do it later. I'll put it on the completed branch, because some of you might still want to go from beginning. Okay. Alright, do you feel that is kind of maybe made some more things possible? In terms of, you know, creating different forms there? Well, hopefully so. Okay, so we can kind of have an infinity of levels spawned if we play this right, using just a very limited amount of blocks. Okay, any questions about this? No, I menu placed it. Have a look here. I just wanted a quick check. Yeah, I wanted a quick check. And the way I did it is because monolith already is a root for those vectors, so you can kind of have a offset, have the start vector on the ground, and then only move the second one by that amount to end up on the where the end vector of this one was. That was all there was to it. But obviously you can treat it recursively too if you want, but I think it's also quite powerful to just run loops, arrays, try randomization, and you'd get quite interesting effects. And the fact that they all talk to each other and kind of not get into their own way will help. So maybe it was worth to kind of like suffer through this three-dimensional arrays and recursion and all those funny bits. Okay. Any more questions from anyone? Remember to enroll in the Brightspace, please. And if you haven't sent me the outline for the project, please do it today or tomorrow. If you still need to polish up or whatever, that's fine. And generally ping me if you have any questions. So otherwise than that, I'll see you next week. Bye bye.